This is Unit 1, Lesson 8. The unit is called Limits and Continuity. The lesson is called Determining Limits to Infinity. What we're going to learn in this lesson is what happens as x approaches both infinity and negative infinity. And we're going to look at some ways to think about it and some methods for determining whether the limit goes to infinity or negative infinity, or if it reaches an actual limit. So some basic ideas. Just to be clear, if a limit approaches infinity or negative infinity, it technically doesn't exist because limits approach a number and infinity is not technically a number, it's more a concept. So for the purpose of this lesson, we want to know if the limit is going up to infinity or down to negative infinity. But in either case, the limit actually doesn't exist. But we want to highlight this for this lesson. So if you consider the limit as x is approaching infinity for x to the power of 2, the limit's going to approach infinity, because you think if you plug in a really big number for x and then you plug in an even bigger number, it's just going to keep climbing up and up and up. If you consider the limit as x approaches negative infinity of x squared, it's also going to go up and up and up, because if we're squaring negative infinity, it's like a negative times a negative, so it'll be a positive. If we consider an odd numbered power, like x to the power of 3, as x approaches infinity, that graph is going to go up and up and up, because a positive times a positive times a positive is still positive. And if we look at as x approaches negative infinity of an odd numbered power, as in x to the power of 3, we will be getting a negative times a negative times a negative, which would still be a negative. So this graph, as we go out to negative infinity, or all the way to left on the graph, it's going to drop down instead of up. And as you can kind of build off of this pattern, any power of x that's an even number is going to approach infinity to the left and to the right of the graph. And any limit as x approaches infinity or negative infinity of an odd numbered power, as it approaches infinity to the right, it's going to go up, and as we go left, we're going to go down. A couple other things to know. The limit as x approaches infinity of 1 over x, which you could also say is x to the power of 1. And the limit for this one is going to approach 0. So the limit for this one actually does exist. And if you think about it, this one makes sense. As we throw in a really big number for x, we're taking 1 divided by a really big number. And the bigger the number, the more we're going to split up the 1, the closer to 0 it's going to get. But it'll never actually, in theory, be 0. Because it'll always be some fragment of infinity. And we can graph that out too and see that it kind of levels out at the x-axis. So now here's kind of a flex one. This is a limit definition for e. E, like pi, is just a symbol for a specific number, transcendental number. It's about 2.718. It's just one of those numbers that occurs in nature. It occurs in finance, population, anywhere where the growth rate is proportional to the compounding period. That's going to be an E proportion relationship. And so the limit as x approaches infinity for this function is going to level out at E. And so we won't work with this one too much yet, but we're just kind of getting our feet wet with some of that kind of stuff. So some examples, polynomial examples as x approaches positive infinity. When we're looking at a polynomial, the only thing that really matters is the leading term and coefficient. So the leading term is the one that has the x to the highest power. So in the first example, x to the power of 5 is the biggest power. And if I take that term, I'm basically multiplying infinity by itself 5 times. And so multiplying infinity 5 times is infinitely bigger than multiplying infinity 3 times, or anything lower than that. I'll say that one more time. Multiplying infinity by itself 5 times is infinitely bigger than multiplying infinity by itself 3 times. So for that reason, none of the other terms really influence the limit of this graph as x approaches infinity. So we only really care about the leading term with the highest power. This will tell us where it approaches, where the limit approaches. So if we consider infinity to the power of 5, that's a positive number, and we're multiplying it by a positive 3. So with a 3 and with 5 infinities, it's like we're multiplying 6 positive numbers together. It's going to stay positive. And because 5 of those 6 numbers we're multiplying are infinity, it's just going to blow up to infinity. And so we can definitely say the limit as x approaches infinity for this function is infinity, or it's going up. Similarly, the second example, we have x to the power of 5 as the biggest term. However, it's got a negative or a -1 coefficient. And so we're going to multiply infinity by itself 5 times, which is going to be positive infinity. And then we multiply that by a -1. Well, that's going to be a negative infinity. So the limit as x approaches infinity for this graph, as the graph goes to the right forever, it's going to drop down forever. Third example, we have the biggest term is x to the power of 4. So we have 4 infinities multiplied together as positive infinity, and then times the coefficient -5 will be a negative times a positive will make it negative, so negative infinity. Last example here, x to the power of 6, that's 6 positives being multiplied, it's going to be a positive. So now let's look at these same polynomials, but instead of as x approaches positive infinity, we'll look at negative infinity. And so the only difference here is that instead of going to the right, we're going to the left on the graph. The biggest terms with the biggest powers are still all we really care about. That's all we have circled. Oh, we just have to consider, now we're putting a negative infinity in for x instead of a positive. So we have to be careful with our positive or negative signs. So if we have x to the power of 5, that's 5 negatives being multiplied together. That's still going to be negative infinity. And then negative infinity times a positive 3 is going to be still approaching negative infinity. Times 3 doesn't change the fact that it's, still a really big number. So we'll definitely say this one as x approaches negative infinity, we're going down to negative infinity. Second one, limit as x approaches negative infinity. Our biggest term here is x to the power of 5. So that's also got a coefficient of negative or -1. So it's 5 negative infinities being multiplied together times a -1. That's 6 negatives being multiplied. So it's going to go to positive infinity. Next one, we have 4 negative infinities being multiplied times a -5 coefficient. So 5 negatives multiplied together is going to be negative. And then for the last one, 6 negatives multiplied together is going to be a positive. So to be clear, the limit for any of these technically doesn't exist, but what we're doing here is we're making sure we have a clear understanding of the end behavior, whether it's going up or going down. All right, so here are some rational functions. So like the polynomials, we care about the leading term, but now since there's a denominator as well, we care about the leading term in the numerator and the leading term in the denominator. If, as in the first example, they both have the same power for their leading term, as in x to the power of 4, then we're going to have a proportional amount of infinities on top and bottom. So then really the limit for this thing, if we simplify this fraction a little bit and just consider the leading terms, we get 1x to the power of 4 over -4x to the power of 4. So really the limit as x approaches infinity of our original rational function is going to be the same as the limit as x approaches infinity of this simplified rational expression that just has the biggest terms on top and bottom. And as we can see, if we cancel out x to the power of 4, we're left with 1 over negative 4. And so that's going to be the limit for our function. A shorter way of saying that, we just have the coefficients of our leading terms. That's going to be our limit. So leading coefficient in the numerator is 1. Leading coefficient in the denominator is negative 4. So 1 over negative 4, or we could say negative 1/4. Now in the next example, we have x to the power of 4 on top as our biggest power, and we only have x on bottom. So if we consider just those leading terms and we cancel an x out on top and bottom, we're left with 5x to the power of 3 over 2. And so we see that there's more infinities on top than there are on bottom. There's 3 more. For that reason, when we approach infinity, this is going to blow up, just like x to the power of 3 would blow up. So we say the limit as x approaches infinity for this one does not exist because it's going to blow up to infinity. Now, if the next example is a similar kind of issue, except the biggest term in the numerator is smaller than the biggest term in the denominator. There's 2 more x's in the bottom than the top. So if we consider just the limit of this rational expression of just the leading terms, we see that we have more x's on bottom. So as we plug in infinity for x, direct substitution, there's 2 more infinities on bottom than top. So for that reason, we're going to, the bottom's going to blow up infinitely more than the top will, which is similar to 1 over x. It means that the limit is going to approach 0. So yeah, we could think of it as canceling off 3 x's from top and bottom. It's going to be the same as the limit as x approaches infinity of 7 over x squared. So 7 divided into infinitely number of pieces is going to be infinitely close to 0. Last example, like the first one, our leading terms are both x to the power of 5. And so their coefficients are going to make up our limit, 2 over 5. So now let's look at 4 more examples, but this time as x approaches negative infinity. Still looking at the leading coefficients, and these are the same ones as before. So we're still looking at the same terms as before. But notice what's the same and what's different. So from going to infinity and going to negative infinity, the leading terms are still what we're going to look at. Our biggest powers are even powers. So when we do a negative infinity, we're multiplying infinity, a negative times itself 4 times. It's going to make it positive over positive. And so when we consider just the coefficients, it's still going to be a positive times a positive on top and a negative times a positive on bottom, which is going to leave it a positive on top and a negative on bottom. So it's still going to be 1/4. Now the next example, if we consider the leading coefficient on top and bottom, we're going to get just the x to the power of 4 and the 2x. But as those two numbers approach negative infinity, we can look at the original or the simplified, just considering the negatives. We're multiplying by 3 negatives in here if we direct substitute negative infinity in for x. And so multiply a negative times a positive is still going to be negative. So this one, the limit as x approaches negative infinity is going to approach negative infinity. It's going to go down. If we look at the original function, we could think of it as 4 negatives on top and 1 negative on bottom. That's still going to turn out to be a positive over a negative. It's still going to be a negative. Now if we see the limit for x approaches negative infinity, for the third example, it's also going to approach 0. And that's because our bottom is going to be an even power. Or if we think the original expression, we have an odd power on top and an odd power on bottom. Odd over odd is still going to be even. And I guess for this one, it really doesn't matter odd or even because it's approaching 0. So that's that one. The last one, again, we have the same power on top and bottom. Yes, there's an odd number of negative infinities being multiplied on top and on bottom each. But because it'd be negative on top and negative on bottom, a negative over negative still makes it a positive. So we have the positive 2/5 is the limit as x approaches negative infinity for this example as well. So takeaways for this lesson, we can approximate or we can determine the limits of functions as x approaches infinity and negative infinity, which just makes limits more fun.